Okay, a second example. A particle is projected horizontally with a speed of 14.7 meters per second. Find the horizontal and vertical displacements of the particle from the point of projection after 2 seconds. Find also how far the particle is then from the point of projection. Okay, so let's just set up the diagram. So we've got our particle. It's being projected horizontally. So ux is 14.7, uy is 0, and it starts to fall, and then 2 seconds later it reaches this point. Now, because it's been projected horizontally, that point is definitely going to be below the point of projection. So if we say that it's going to have a horizontal displacement of x and a vertical displacement of minus y, and at this point t is 2 seconds. So if we just have a little run of writing down what we know from a variable point of view, sx is x, ax is 0, ux is 14.7, t equals 2, and in the vertical plane sy is minus y, ay is the acceleration due to gravity, so minus 9.8, uy is 0, and t equals 2. Using the same Suvat formula, s equals ut plus a half at squared. We can set that up as a vector to cover both horizontal and vertical. So we have x minus y equals 14.70 for the ux and the uy, plus a half 0 minus 0.98, and sorry, this time it's times t, which we know is 2, so that's going to be times 2, and that's going to be 2 squared. Separating that out into its horizontal and vertical, I'm going to have x equals 14.7 times 2, which is 29.4, and y, I've got minus y equals, that's going to be 0, and this is going to be half times that is minus 4.9, I don't know where that fly's come from, times 2 squared, which is 4. So minus y is minus 4.9 times 4, so y is going to be 4.9 times 4, which is 19.6 meters. So go back to the question, find the horizontal and vertical displacements of the particle from the point of projection. So it's going to be horizontally 29.4 meters away, and it's going to be 19.6 meters below the point of displacement. So therefore particle is 29.4 meters horizontally, and this one, because it's involved the acceleration due to gravity of 9.8, we're going to round to 2 significant figures, and to 2 significant figures that is going to be 20 meters. 2SF vertically below. Okay. Find also how far the particle is then from the point of direction. So you may wonder, well, we've just done that. We know it's 20 meters in the horizontal plane and 29.4 horizontally and 20 meters vertically. What they actually want in order to find out how far it is from the point of projection is they're asking you to figure out as a direct line from the point of projection to where it is. So they're looking for this distance d. And that distance d is going to be the, if we just draw it here, so what we've got is we've got from the point of projection a horizontal distance of 29.4, a vertical distance of 19.6, and they want to know what the hypotenuse is. So to answer the question, find out also how far the particle is from the point of direction, it's that direct as the bird flies distance, which we get using Pythag with 29.4 squared plus, and remember, don't use the rounded version here, so plus 19.6 squared, and when you plop that into your calculator, you get 35.3344. So write the whole thing down and then say equals 35 meters to 2SF. Okay, so that's eg2.